Today we will discuss about the reactions of the aldehydes and ketones. So as you know that aldehydes and ketones, what happens, C double bond O is common, and in aldehyde one hydrogen will be there, so CHO. But our main concern is to remove the C double bond O. We can replace it by hydrogen, that is CH2, and we can say that it has undergone reduction. So this can be done in two ways. The first one is a name reaction, which is known as the Clemmensen reduction, and the second one is known as the Wolff-Kishner reduction. What happens in the Clemmensen reduction is that the aldehyde or the ketone is taken, and then zinc amalgam is added in the presence of hydrochloric acid. Then reduction occurs in which oxygen is being replaced by two hydrogen with single bond. Here also two bond is there in terms of double bond, but here single bond will be there. Okay, and this is how reduction takes place. So hydrocarbon is formed here, right? From the carbonyl compound, hydrocarbons can be produced by the Clemmensen reduction, along with the production of water molecule, that is a byproduct. Again, for the Wolff-Kishner reduction, you have to take hydrogen, NH2. This molecule is known as hydrogen, and if you observe here, this oxygen is replaced by NH2. From this hydrogen, one H2 will be released. H2 will be released, and this will bind up with oxygen to produce the water molecule, which is produced as a byproduct and can be removed, right? So this oxygen is being replaced by NH2. One H2 is removed, so this is NH2. Now to this molecule, KOH, potassium hydroxide or ethylene glycol, is used in is heated. This is mixed with this molecule, and then both are heated. Then it will undergo final result, that is the reduction product, that is the hydrocarbon plus nitrogen gas is released. So this is the difference between Clemmensen reduction and Wolff-Kishner reduction. Here you can see the products are both same hydrocarbon, but the process, the reagents are different here. In the first one, you have to use zinc amalgam and hydrochloric acid. In the second one, first of all, you have to use hydrogen, and here one water molecule is released. Next, you have to take potassium hydroxide and heat it with the intermediate compound. Then you will get the resultant compound, that is the hydrocarbon. So in this way, the carbonyl compounds undergo reduction process by the name of Clemmensen and Wolff-Kishner. Next, if we talk about oxidation, so aldehydes and ketones both undergo oxidation, but for aldehydes it becomes easier, and for ketones you have to do extensive or under vigorous conditions. You have to apply some vigorous conditions in order that the ketones undergo oxidation, and that can be done by using strong oxidizing agents and at high temperatures. So here you can see aldehydes differ from ketones in their oxidation reactions, as we have already discussed just now, right? So aldehydes are easily oxidized to carboxylic acid. You have to remember this thing, that aldehydes are oxidized to carboxylic acid. What we have learned here is that aldehydes and ketones undergo reduction to form hydrocarbons. They undergo oxidation to form the carboxylic acid. And then ketones, for ketones you will need strong oxidizing agents. So if in the question it comes that which compound undergoes better oxidation, then answer will be aldehydes. Aldehydes can undergo oxidation very easily as compared to the ketones, right? So here also carboxylic acid is produced, and here also same thing, carboxylic acid is produced, right? But if you see here, one important thing is that the carboxylic acid will produce the ketones will produce two carboxylic acid. One is being broken here with this alkyl chain, right, R dash, and another one with this. So this thing you have to keep in mind. There is another possibility that RCH2 COOH is produced or R dash COOH is produced. So you can see this difference here. This alkyl chain will take up the CH2, or this alkyl will take up the CH2, right? So let us read here. Their oxidation involves carbon-carbon bond cleavage, right, to afford a mixture of carboxylic acids having less number of carbon atoms than the parent ketone. So if you see here, what you can observe, 1 2 3 4 5, total 5 carbon is there, right? 1 2 3 is sure. Then these are the what, alkyl chains. Minimum it can have 5, because if we take here CH3, here also CH3, minimum 5 is there. Maximum you cannot say, because it can be CH2 CH2 CH3, right? So minimum at least 5 carbon atoms can be here. But in the product side, if you see the carboxylic acid, which is the oxidation product, you can see here the carbon atoms has changed here. It has become less because you are breaking the carbon-carbon chains here. So the carbon atom is becoming less here. This thing you have to keep in mind. Next is that the mild oxidizing agents given below are used to distinguish between aldehydes from ketones. So how you can distinguish between aldehydes and ketones? So that can be done by using tolerance test and Felling's test. So we are not going to discuss in details about this, okay? Tolerance test is shown by aldehydes. On warming an aldehyde with a freshly prepared ammoniacal silver nitrate solution, a silver mirror is produced, okay? And this is the reaction which is not required actually for your board examinations. You can just remember that aldehydes undergo tolerance test, while the ketones do not show any significant observation for tolerance test. And what is the reagent that is used in tolerance test? That is your ammoniacal silver nitrate solution. And for Felling's test, 2 solutions are being added here. The first one is the aqueous copper sulfate, and the second one is the sodium potassium tartrate. So you can also say as Felling A and Felling B. In short, we say Felling A. So Felling A is aqueous copper sulfate solution, and Felling B is known as the sodium potassium tartrate. So these 2 names you have to remember. And how it is done? These 2 solutions are mixed in equal amounts before test. So Felling A and Felling B is mixed in equal amounts, and on heating an aldehyde with this reagent, so that heated mixture is treated with the aldehyde and then again heated, what happens? A reddish brown precipitate is obtained. So aldehydes are oxidized to corresponding carboxylate anion. Aromatic aldehydes do not respond to this test. This is an important line. Aromatic aldehydes do not respond to this test. So the summary of this whole paragraph is that the aldehydes show tolerance test as well as the Felling's test, while the ketones do not show. Now what is the reagent used in Felling's tolerance test? That is your ammoniacal silver nitrate solution. And what is used in Felling's test? That is Felling A and Felling B. Felling A is aqueous copper sulfate, Felling B is sodium potassium tartrate. Clear? And another important thing is that aromatic aldehydes do not respond to this test. Okay, so this thing you have to keep in mind in this paragraph.